Abel's limit theorem. If sigma 0 to infinity a n converges, then f of z equals to 0 to infinity a n z raised to power n tends to f1 as z tends to 1, such a manner that modulus of 1 minus z upon 1 minus modulus of z remains bounded. Now proof without loss of generality. We suppose that sigma an equals to 0, therefore f1 is equal to 0. Now set Sn is equal to a0 plus a1 plus so on plus an. Consider the identity Sn z is equal to a0 plus a1z plus a2z square plus so on plus a n z raised to power n equals to s0 plus bracket starts s1 minus s0 bracket close into z plus bracket starts s2 minus s1 bracket close z into z square plus so on plus bracket starts sn minus 1 bracket close z raised to power n equals to s0 1 minus z plus s1 z minus z square plus so on plus sn minus 1 z raised to power n minus 1 minus zn plus sn z raised to power n equals to 1 minus z into s1 s bracket starts s0 plus s1 z plus so on plus sn minus 1 z raised to power n minus 1 bracket close plus sn z raised to power n. But Sn z raised to power n tends to 0, so that we can write f of z is equal to 1 minus z sigma 0 to infinity Sn z raised to power n. Since 1 upon modulus of 1 minus z upon 1 minus modulus of z remains bounded for all values of a positive, there exists a positive constant such that modulus of 1 minus z upon 1 minus modulus of z is less than equal to k. Equation 1. Again, Sn tends to 0 and as n tends to infinity, for the given epsilon greater than 0, there exists a positive integer m such that n is greater than equal to m, which implies as modulus of Sn is less than epsilon. Now modulus of f of z is equal to modulus of 1 minus z 0 to infinity sigma 0 to infinity Sn z raised to power n modulus close is less than equal to modulus starts 1 minus z sigma 0 to m minus 1 Sn raised to power z n modulus close plus modulus starts 1 minus z sigma m varies from 0 to infinity Sn z raised to power n modulus close. Means sigma is divided into two parts. One is 0 to m minus 1 and another is m to infinity. Now which is less than equal to sigma 1 minus z less than equal to modulus of 1 minus z sigma 0 to m minus 1 Sn z raised to power n modulus close plus modulus of 1 minus z sigma m vary from 1 to infinity modulus of Sn into modulus of z raised to power n is less than modulus of 1 minus z sigma 0 to m minus 1 Sn z raised to power n modulus close plus modulus of 1 minus z sigma m varies from 1 to infinity epsilon z raised to power n by 2. So which is equal to 1 minus z modulus of modulus of 0 to sigma 0 to m minus 1 s n z raised to power n modulus close plus modulus starts 1 minus z epsilon modulus of z m upon 1 minus modulus of z, summing the GP series less than equal to modulus of 1 minus z sigma 0 to m minus 1 s n z raised to power n modulus close plus epsilon modulus of 1 minus z upon 1 minus modulus of z, which is less than equal to 1 minus z modulus sigma 0 to m minus 1 modulus of s n z raised to power n plus k epsilon by 1. So the first term of the right hand side can be made arbitrarily small by taking z sufficiently close to 1. It follows that f of z is equal to 0 equals to f of 1 as z tends to 1 subject to the stated conditions.